If Mary Murray is standing on top of a 35-meter tall tower and jumps out at a 0-degree angle with a horizontal velocity of 2.3 meters per second, will she make it to a pool that is a horizontal distance of 0.73 meters away from her initial jump point? What will her final velocity be before either she goes splat or she goes sploosh? Okay, well, this is a pretty complex problem, so I'm going to draw a water tower here. And I'm going to draw a pool. Okay, and let's put Mary in a purple dress. Okay, and so Mary leaves the water tower, and she is leaving the water tower with a horizontal velocity of a velocity initial of 2.3 meters per second. And she's going to go, the question is she going to make it to the pool or not? We know that she's standing a distance in the y of 35.0 meters. And since we know she's going to travel in this direction, it's a negative number. Okay, now you'll see that I haven't given you any hints necessarily, but you need to be very careful because I know that you're looking at this number going, hey, that's a given. You got to be careful though, because 7.3 modifies the pool. It does not modify Mary Murray. There happens to be a pool 7.3 meters away. That does not have any bearing on whether Mary is going to make it to the pool or not. Now, I've been a little bit tricky because one of the givens that you are going to need before you can figure out what the distance in the x-axis is going to be is you're going to need to know time. And so on a scrap of paper or in the corner here, I'm going to very quickly establish what I know in order to go figure out time. So I have a givens. I know distance in the y is negative 35.0 meters. I know that acceleration due to gravity I know that distance in the y equals negative 35.0 meters. I know that the acceleration due to gravity is negative 9.8. I know that velocity initial in the y is 0 meters per second. I can go figure out time to fall. And once I figure out time fall, then I can apply it in either one of these sets of givens. So distance equals velocity initial times time plus 1/2 acceleration times time squared. Negative 35.0 equals 0 times t plus negative 9.8 times t squared. All that over 2. This blows up, leaving me with negative 35.0 equals negative 9.8 t squared, all that over 2, multiply by 2, cancel, cancel, giving me negative 70.0 equals negative 9.8 t squared. Divide both sides by negative 9.8. T squared equals 7.142857 square root 1 square root the other. Time equals 2.672612 seconds. Okay. And now I can use that information in order to help me in both the x and the y axis. So I can use this as a given. Let's see, what else do I know? In the x-axis, well, hey, I know that velocity initial equals 2.3 meters per second. And I know that Mary, when she jumps, right, her velocity is still going to be 2.3 meters per second. Is she speeding up? Is she slowing down? Is she accelerating in the x-axis? Nope. 0 meters per second squared. So now I need to find a phenom that deals with distance, acceleration, velocity, and time. If you haven't seen a pattern yet, well, let's see. Distance, I don't know what that is, but I do know that velocity initial is 2.3 times time, which is 2.672612 seconds, plus acceleration, which is 0, times 2.672612 squared, all that over 2. Well, the 0 here, multiply a number times 0, you get 0. Then 0 divided by 2, it just all blows up, giving me a distance in the x-axis of 6.147076 meters. Let's figure out significant figures. There's 3, there's 2. So I'm going to apply 2 sig figs. 6.1 meter. Wow, wait a minute. So that's my answer for the first one. What happens to Mary? Mary actually ends up traveling 6.1 meters. But hold on a minute. Where's the pool? The pool is 7.3 meters. I think Mary's going to have a bad day, and she's going to go splat. Okay, well, now that I know that, how fast is Mary moving? Now, some students will go, well, is that in the x-axis or the y-axis? If it's in the x-axis, it's kind of a moot point. I already know how fast she's moving right before she hits the ground. But what is much more interesting is her velocity final in the y-axis. Okay, let's take what I know. I do know a time equals 2.672612 seconds. Let's see. I know a distance, displacement, equals negative 35.0 meters. And I know an acceleration due to gravity equals, and I know a velocity initial equals 0 meters per second. Now this one's a little bit different. It's not my standard phenom. So I want to talk about velocity finals, distance, velocity initials, distances, and times. And so I'm going to use velocity final squared equals velocity initial squared plus I'm going to use distance equals 1/2 velocity final plus velocity initial times time. So negative 35.0 equals velocity final, which I don't know, plus velocity initial, which is 0, times time, which is 2.672612, all of that over 2. Okay, in order to simplify, I'm going to multiply this side by 2 and this side by 2, so this cancels, giving me negative 7d equals velocity final plus 0 is still velocity final, but it is multiplied by 2.672612. In order to get VF all by itself, I'll divide by 2.672612. Cancel. Whatever I do to the right, I got to do to the left. And when I do the math, velocity final equals negative 26.191606 meters per second. Apply significant figures. See 2. And I get negative 26 meters per second. Okay, so she missed the pool. Is she traveling very fast when she hits the ground? Yes. I think Mary is going to have a bad day.